All right, good morning or good afternoon or good evening, depending on when you guys are looking at this video. We're getting into chapter 10 now, so we're going to be working with a little bit of probability. The first thing, conditional probability, as well as independence. We're going to work through a CPM lesson, so the assignment for today is to follow along and take notes. You don't have to copy every single word down, but please copy down anything that I write and possibly the question or part of the question. So like it says here, we're going to be working with the idea of, any kind of event and how to calculate the probability of that event occurring. That's something you've done in the past, hopefully, but now we're also going to work with, if you look here, when two events occur. So if that happens at the same time or back to back, either way, we want to figure out the probability of one of those things given we already know about the other thing. And if that doesn't make sense, don't worry, we're going to go through some examples. The first one here is with this game being played called Eight the Hard Way. So as it says, Maribel is playing the board game Eight the Hard Way with her friends. So the way the game works is each player rolls two dice. So as it says here, two dice, those are actually the two events that we're talking about in this case. So each player rolls two dice and moves according to the sum on the dice. But if a player rolls two fours, called Eight the Hard Way, they instantly win and a new round is started. So it says here that Shayna stepped into the kitchen to get snacks, so she didn't have a view of the game, but she heard Maribel shout, "I got an 8." So that can happen in more ways than one. All she knows is that Maribel got an 8. So it says here that we need to investigate the probability that Maribel rolled two fours, and won the round of play. So that is the idea of conditional probability. What is the probability that Maribel rolled two fours given we know she already rolled an 8? So the reason we can't just immediately say one probability is we have to calculate two different things. The first thing we're asked to do here is actually create a table to represent all the different sums of numbers when rolling two dice. So each die has 6 different numbers that could pop up. So I'm actually going to create this table, and if you want to take a second, you can pause the video and create this 6x6 grid. So we're going to be using this to represent all the different ways that a dice or a pair of dice could be rolled. The reason for that, and again, take a pause for a second and copy this down. I will wait and then we'll get started. So the reason that we have this table is if we have die number 1 up here and die number 2 over here, each of these has a possibility of rolled 1, 2, 3, 4, 5, and 6. And the same thing here, 1, 2, 3, 4, 5, and 6. So those are all of our possible rolls. And I'm actually going to, make this a little bit smaller so we can fit everything in there. But when we are creating a table with all the possible sums, we want to add the two together. So 1 and a 1 would be 2. 2 and a 1 would be 3. 3 and a 1 would be 4. And if you notice, we just go 2, 3, 4, 5, 6, 7 all the way across. This is a 3. And there is sort of a pattern going on here. So we can fill this table in somewhat quickly. 1 and 3 is 4. And then we go 5, 6, 7, 8, 9. 1 and 4 is 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11, and 7, 8, 9, 10, 11, and I call it boxcars. When you roll 2 6s, that would be a 12. So that is our final result of the table. So take a second to copy it down, pause the video if you have to, because we're going to use this for the rest of the questions on this problem. So with part B, it says, since you know that Maribel rolled a sum of 8, our sample space has changed. So if we just were told, what are the chances that Maribel rolls 2 4s, we could quickly calculate that. But there's another piece of information. We know that she rolled a sum of 8. which means only the 8s are now part of our sample space. So in our table, we're being asked to shade all the ways that an 8 can be rolled. So if we look at that, and I'll get to my highlighter, I see a few 8s here. So this could be rolled. That would be a 2 and a 6. A 3 and a 5 could be rolled. A 2 and a 4, or 8 the hard way. A 5 and a 3, and a 6 and a 2. Notice that you can roll a 2 and a 6, or a 6 and a 2, and a 3 and a 5, or a 5 and a 3, depending on which die has which number. So the question we're asked now is how many different ways can a sum of 8 be rolled? So that's the total number of outcomes. So the total number of outcomes in this case, the number of ones that I shaded is 5. So total number of outcomes is 5. So that's our final answer for that one. But part C, we are interested in the event 8 the hard way. How many different ways can 2 4s be rolled? So if we look at this, that and that is the only way, that one box that those 2 4s pointed towards, that is the only way that you can roll 8 the hard way, which means the total number of outcomes, or successful outcomes, 2 4s, is going to be 1. So now we know 2 pieces of information that are going to help us calculate our conditional probability. The next question is asking us, what is the probability of the event 8 the hard way, given you know Maribel rolled a sum of 8? So the way we calculate probability is the number of successes, so the number of ways that we get what we want to happen, over the total number of outcomes. So in this case, our number of successes, the number of ways that we can roll 8 the hard way, is 1. But the total number of possible outcomes, that would be this up here from part B, is 5. So that means we have a 1 in 5 chance of getting 8 the hard way, given we already know that 8 was rolled. That's because of these 5 shaded, only this one right here is 8 the hard way. So that's that 1 out of 5 idea. So another example of this, we'll do this one a little more quickly. It says Becca rolls high, which means that she rolled a sum of 9 or more, a sum of 9 or more. So we want to know the conditional probability that she rolled an odd number, given that you know she rolled high. So the first thing we're going to do is similar to what we did in the last example. Let's go ahead and shade all the ways that you can roll a high sum. That would be anything 9 or greater. So that would be 9s, 10s, 11s, and that 112 right there. So our total number of ways that you can roll a high outcome, it looks like, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 high rolls. So the reason that helps us is because we're being asked, if we know they rolled high, what is the probability of rolling an odd number? So the ways to roll odd and high, in this case, if we go back to this 10 different rolls, these 9s right here are odd, and these 11s right here are odd. Out of the 10 high rolls, these are the ones that are also odd. So that would be 6, it looks like, that I've circled. So the number of successes, which is rolling an odd, over the total number of outcomes, so total outcomes. Same probability calculation, and it looks like that is going to be that 6 all over the 10. So we now have our probability. We know that she rolled high, which is 10 different ways, but the probability that it was also odd is those 6 that I circled. So for the next question, this is what is called a two-way table. So I would like you to maybe label off to the side that this is a two-way table. And this table right here is not fully completed. So if you could take a second to copy down what we have so far, pause the video and copy it down. And then we are going to fill in the rest of this. So what this table right here says is we have data on engineering majors. So all of these numbers represent a different person at the school, a student at the school. In this case, this 30, for example, represents somebody who is an engineering major and lives off campus. So there are 30 people who are engineering majors and live off campus. This 6 right here represents 6 different engineering majors who live on campus. So with that information, we actually know the total number of engineering majors. There are 6 that are on campus, 30 that are off campus, which means there are 36 total engineering majors. And then we have 170 other majors that live off campus, and we have 34 other majors that live on campus, which, if you add those two together, tells you there are 204 other majors. We can also call these margins or totals. So if we go the other direction, so horizontally, we know the total number of people that live off campus. That would be over here on the right-hand side, and that's 200. This 30 plus that 170. That gives us our total number of people off campus, and 40 that are on campus. This bottom right corner, which is the margin of the margin, basically, is the total of those reds. So we know that there are 36 and 204. If we added those two together, there are 240 people total at the school. Notice that 200 and that 40, so over here, also add up to 240. Those numbers always have to add up correctly on both margins. So with that information, we can answer the questions. So if you have that copied down, we'll answer this first one. We want to know the probability of a student living on campus at Einstein Technical University. So that's where we're going to go to our totals. So the number of people that live on campus, it looks like, is this 40 right here. So the way that probability works, again, we calculate it by saying the number of successes, or the number of what we're looking for, that's what that successes means, all over the total number of outcomes. In the case of people living on campus and the total people at school, it looks like the number of successes is going to be that 40 right there, so we'll call that 40, out of our total 240. That ends up being 40 out of 240, which is actually, I think we could simplify that to 1 over 6. And that is also about 16.66%. So that's another way that we could represent our answer. I will accept either answer always when it comes to probability. Next part, we're asked to copy the table. So we already did that. If you haven't, then please do. Now we're asked to shade the cells that include engineering majors. So I'm going to quickly go up here and do that. Please do the same. It's a highlighter or just lightly using a pen or a pencil. So we're going to shade in the engineering majors. So that would be this 30 right here and this 6 right here. So that 36 total. And we're asked, what is the conditional probability? So again, finding the probability of something given we know something else. So the probability of a student living on campus given you know that they are an engineering major. What that does is it changes our total number of outcomes. So last time our total number of outcomes was 240 because we were talking about all the students. But now our total number of outcomes is just the engineering majors. That means that there are 36 on the bottom. So our bottom is going to be 36, and then we want to calculate the probability of a student living on campus, which if you look at it, there are 6. So we actually have 6 students living on campus out of a total of 36 engineering majors. That simplifies to 1 over 6, which is also 0.166 or 16.6%. Any of those answers work. So that would be